So for problem 1, the question is to consider the following questions concerning keto-enol tautomerization. And the question says rank the following carbonyl compounds from highest to lowest KEQ for enol keto tautomerization. So the highest equilibrium constant is going to be the molecule that is most prone to undergo is most prone to form the enol form of the molecule. So there's a couple things that you should look at these molecules and see. The first one is that this molecule cannot undergo keto-enol tautomerization, and that's because this is a quaternary carbon right here. So enolization would give 5 bonds to that carbon, which is obviously not a good thing. So then you have these two groupings of a beta diketone and a beta keto ester. So let's first look at these. So the question is, which of these two is going to be more prone to go to the enol form? So I think that if you ask the question just by itself of a ketone versus an ester, and we discussed this in class, why a ketone is much more prone to go to the enol form as compared to the ester. And there's a lot of ways to rationalize this. One way is to say that because you have these lone pairs of this oxygen, this will already be less prone to undergo enolization. You could also say there's already more electron density here. You could say that this system is electronegative. So regardless of how you want to say it, but having 2 carbonyls is always going to be a better situation than having 1 carbonyl for enolization. So this is the most prone to enolization, followed by this because it has a ketone and an ester. All right. And so then you look at the aldehyde versus the ketone. And so here what you have to realize is that having that extra methyl group on there will give you a very small amount of inductive donation into this system. So that would say that because you have inductive donation to this system, this is going to be less likely to undergo enolization. So this is going to be 3